Hi, everybody. My name is Dana Hoffman. I am a software engineer at Google.
My name is Paul, and I am a software engineer for eBay.
And today we're going to talk to you about how eBay jumpstarts developer productivity with Google Cloud Platform and Terraform Apply. So I think, see you in a little bit.
See ya.
So I'm going to talk to you a little bit about Google Cloud Platform for now. Who here has used Google Cloud Platform or is using it now? Show of hands. Oh, a lot of people. Awesome. Who here has used Terraform? Also, yeah, pretty much everybody. That's wonderful. So Google Cloud Platform, Google's mission, as you've probably heard before, is to organize the world's information and make it universally accessible and useful. And so when we started off at Google, we were doing that through Google Search. And over the years, we've come up with a whole bunch of other products. You can see a few of them on this slide here. The ones that I featured are the ones that now have 1 billion users. Now, to have products with 1 billion users, you need really, really good infrastructure. You need infrastructure that scales. You need infrastructure that's fast. You need it to work for anybody, no matter where in the world they are. And we've done that. We've done that really well. You can use Google Search really well. You can use YouTube wherever you are, Google Maps, and everything else. And so we want to offer that to you for your company as well. And so because of that, we have Google Cloud Platform. Google Cloud Platform, or GCP, lets us bring this battle-tested infrastructure to you. So you can focus on solving the problems at your company, the ones that you really want to solve, and we can focus on hosting your services, scaling data centers, all of that stuff. You get to run your applications on the same infrastructure that we use to power Google. And so I'm just going to quickly breeze through a few features of GCP that set it apart from the other cloud providers. So we have the largest network, which runs on our own private fiber, with global load balancing and scaling that can scale to over 1 million queries per second with no pre-warming, just pretty much instantly. We have really good compute infrastructure with fast boot times, live migration, so you have less downtime. It's super reliable. And we let you put in custom machine types, so you can customize it to whatever needs you want. We're also really cost-effective. We enjoy helping you save money because we want you to be paying for what you're actually using. It brings us no joy to just sell you a bunch of machines that go unused. We want you to be doing really cool stuff on our infrastructure. And so we give you cost incentives to make sure that you're actually using what you've paid for. And now something that you might not realize about Google is that we're actually a leader in open source. So you've all who heard of Kubernetes, you've probably all heard of TensorFlow. These are some open source contributions that Google has made in the world. But we also contributed Google to a whole bunch of other open source repositories. So we've had over 200,000 commits by Googlers on open source projects, 15,000 projects contributed to, and 2,500 projects that have had at least 10 events from Googlers. So these are projects that Googlers are actively contributing to. That's over 2,500 of them. That's astounding. And so that brings us to here where we are today. We love contributing to HashiCorp. We have a team of engineers at Google whose full-time jobs are to make sure that developers using HashiCorp tools have a really, really great experience with GCP. So you can see us in the photos up there. That's me, Joe, Vincent, and Emily. And the first three of us mostly focus on Terraform. Emily mostly focuses on Vault. I hope you got a chance to hear her presentation earlier today. Or if not, check it out another time. We also have a few other people that contribute from across the organization, not necessarily directly with engineering, but with some other things. So we have Dan from our solutions architect team, Martin and Maya from product management, and all 7 of us are here at HashiConf today. You can come talk to us in the booth along with a few other Google employees who would love to talk to you about cloud and Terraform and other HashiCorp products. And so here's a screenshot from the Terraform provider for GitHub, for Google in GitHub. As you'll notice, a lot of Googlers are contributing to this. And this is really, really great. for everybody. So having Google employees contribute to Terraform means that the people that are actually writing the Terraform provider for Google are the ones that can go and talk to the product teams. So for example, there was a feature in Container Engine, resizing a cluster. It wasn't in Terraform. And the reason it wasn't in Terraform was because it wasn't exposed in the Google API. People asked for it. I work at Google. I went up to the Container Engine team. I said, can we have an API endpoint for this? It's something our users want. They said, OK. And they created it. And as of the next release of Terraform, you'll be able to resize a container cluster. This is something that having Googlers directly involved in the product allows you to do. I also just want to shout out to our friend Patty, who works at HashiCorp. He's the only employee up there that's not at Google. And he provides a really great bridge between us and the way that we want to do things and the way that HashiCorp wants to do things. We align almost all of the time, but it's really nice to have that extra connection, that little bit of person-to-person stuff going back and forth between the two companies. And so why is Terraform and GCP so great? So a lot of you in the audience are already using Terraform, and you're already using GCP. So this is going to be like super old news for you. But infrastructure is code. I'm going to go ahead and make the claim that it is necessary for cloud resource management. When you're using the cloud, you want to be able to focus on your core business, right? You want to be able to let other people that are experts at cloud, handle your cloud. And you want a similar thing with your infrastructure management. So things that you might want are version control, reproducible infrastructure for different environments, and an easy way to view your full infrastructure, whether that's at the time you're about to make changes to it or after those changes have been made. Now, Google offers a few tools for managing your cloud infrastructure. We have a cloud console. It's really great. It's a nice UI. It's fast. It works. It's really pretty. But you can't version control your UI. And if you want to put stuff in different environments, you just have to do it multiple times. It's a super great way to get started. It's really easy to use. But once you want to actually be using cloud infrastructure in production, there's only so much you can do with that anymore. We also offer a command line tool, gcloud, which does a lot of the same thing. Now, if you're using a command line tool, again, for your production infrastructure, you're probably going to end up writing scripts around it so that you don't have one person add a command line every single time you want to change something. If you do, that's fine. It just falls into the same category as the cloud console. So you write a script. You can version control that script. Reproducible infrastructure for different environments, well, now you have to make sure that your script can do that. Does your script have certain ways of having variables that it makes so that you know, well, this is how I want to configure our test environment. This is how I want to configure our prod environment. An easy way of viewing the full infrastructure, well, again, you're writing that into your script. Because if your script is just calling gcloud, it's just going to do what you ask it to do. And so at this point, why would you reinvent the wheel? Why would you try to have personnel on your teams writing these scripts when you could use something that already exists out in the world that's been written by experts? Another big reason why we at Google really enjoy contributing to Terraform and think that it's a really great way to configure your cloud is its multi-cloud support. So earlier today, I was talking in the booth to some people, and they came up to me and I said, hey, are you a Google Cloud customer? What can I tell you about GCP? And they're like, oh, we are, but we also use another cloud. We don't only use Google. I'm like, that's OK. Multi-cloud, it's not a dirty word. It's actually a really great thing. And by using a tool like Terraform, you can really, really easily configure multiple clouds. And so if you want to just play around with adding a new cloud into your architecture overall, or you're already set on multi-cloud, using a tool like Terraform is one of the only ways that you can do this in a way that's really, really easy and version controlled, and you can reproduce stuff in different environments. And so up here, I just have a quick example of how you might do multi-cloud. So you notice up here, I've got a Google resource. It's a VPN tunnel. And it has a field called peer IP. And that peer IP, the value, is set to an AWS resource. And this just works. You don't need to do anything special. You don't need to tell Terraform, hey, create this AWS resource, get an output from it, and then once you're all done, then create a Google one, like you might do if you were using a script or something like that. You just say, well, this one depends on this. This is the value that I want, as if it were any sort of other variable. And then Terraform understands. It creates the dependency graph, and it'll create the resources in the order that you need. And then if you want to update it later, say that IP address from AWS has changed, well, Terraform understands that means that we need to recreate the Google resource because there's been a change. And you can't get that with the Cloud Console, you can't get that with scripts, and you can't get that with the infrastructure as code mechanisms that the various cloud companies are offering today. So Terraform is really, really useful for our customers. And so at Google, we want to do what's best for our customers. And having the best Terraform support possible is going to do that. So having the best Terraform support possible, I've talked a little bit about compute infrastructure and networks and that sort of thing, but Terraform and Google supports more than that. We support resources across the full spectrum of what Google offers in a couple of different categories. Woo, preview. OK, since last HashiConf, so I'm sure most of you probably were not at last HashiConf because from the keynote this morning, I learned that about 70% of us are new this year, which is super exciting. Since last HashiConf, our team has sprung up. We exist. We are full-time engineers that work on Terraform at Google. And we've done a lot in that year. We've added over 30 new resources and data sources, including a ton of bug fixes and resource improvements across the board. So I divided this up into 3 categories to show you because it was too much to fit on just one slide. So in terms of compute, some of the features that I want to highlight from here, I know it's a lot of text, you don't need to read it all. It's all in there, changelog and posted in the docs on terraform.io. We've added 2 new really great networking features, internal load balancing and shared VPC, otherwise known as cross-project networking. We've also added the ability to supply your own customer encryption key for disks. And we have the infrastructure now to support APIs that are in beta. So if you have a feature that you want that's in Compute Engine, that's a beta feature. We used to not be able to add it to Terraform. Now we can. And so that's all come up somewhat recently. On the data side of things, we've added support for BigQuery, Bigtable, and Spanner. This is in addition to Cloud Storage and Cloud SQL, which we've already had support for. And in my last miscellaneous other category, we have this new feature for full project lifecycle management. And this involves pretty much all of the resources that I've put up to the side. And even though I have only one feature that I listed right here, it's a really, really big one. And so I'm going to talk to you a little bit about it right now. So in Google Cloud, this is how the resource hierarchy works. If you're familiar with other cloud providers, you might be a bit confused right now because there's nothing on here that's called an account or a user. Everything is broken up into projects. Projects can be out existing in the world, or they can be owned by a folder. Folders can be owned by organizations. Projects can also be owned directly by organizations. And IAM is inherited down the chain. So if you have your team called Team B, and you want to make sure that they have edit access to any resource that's created underneath it, I don't know why this is happening. Team B, you take that Google group that corresponds to that team, and you give it the IAM policy of editor, and then everybody that's in that Google group has access all the way down the chain. And so if somebody leaves your team, you remove them from the Google group. Now they can't access the things anymore. Somebody new joins the team, you add them to the Google group, and now they have access to everything that they need. It makes things really simplified. You don't have to worry about people leaving the company and accidentally taking resources with them. I mean, that's not literally how it happens, but it makes it pretty convenient. And with all these different projects that you can separate things out to nicely, we now have the ability to have them talk to each other on Google's private network through shared VPC. So you can have a host project which creates a network, and then other projects that can still talk to each other within that network, even though their instances were created on different projects, potentially by different teams with different sets of IAM policies. And so some upcoming integrations that you might be curious about. I talked a little bit about folders right now, which is not actually available in Terraform yet. In our next release, we'll have the ability to create folders and update them in Terraform. And very, very soon, we'll have the ability to do the full folder lifecycle management. We also are working on a few other integrations. So here's a little sneak peek of what's coming down the line. And now I've talked a lot about my team, the engineers at Google who are making this all happen. But we really can't do it without our community. There have been over 100 contributors to the Google provider over time. This is a lot more than there are Googlers that are working on this. So if you have a feature that you'd like to see and you'll enjoy contributing, feel free to file a pull request. We guarantee that any PR or issue that's filed gets eyes on it within a week. Usually it's a lot sooner than that. We don't always respond right away, but we'll at least look at it and give it a good, honest look through to see whether we can add it, and pretty much everything does end up making it in eventually. Issues. This is the best way to tell us what you want in Terraform. Sometimes people will come up to me and they'll say, hey, is Terraform support coming for this thing? And I'll say, oh, I had no idea that anybody actually wanted that. So let me know what you want to see in Terraform by filing an issue or thumbs-upping an issue that's already there. When we're doing our planning to figure out in a given quarter what we want to focus on, that's one of the biggest places that we look is just the issue tracker. And if your company has contacts within Google, either in the sales organization or support or anything like that, tell them too. You usually know who I am and talk to me, and that's the other way that we prioritize what to work on. And lastly, if you're curious what we're focusing on, aside from the little sneak peek that I gave you before, you can check out the projects tab up on our GitHub, where I try to keep that pretty much up to date with quarter by quarter. Here's what we're working on now, here's what we're thinking about, here's what's actually really in progress, that sort of thing. And lastly, if you ever just have a quick question or feel like chatting, you might not know that there is a Google Cloud Platform community Slack, and within that there is a Terraform channel. And so feel free to go ahead and join that, and if you go to that URL, you can get an invite for the Slack. I'll leave the slide up for a little bit for anybody that's taking a picture to see, to get that URL. And you can contact me that way, you can contact my team that way, and you can contact a bunch of other people that are using Terraform with Google Cloud Platform. And so with that, I'm really excited to welcome Paul to the stage to share with you how they're actually using Terraform with GCP. It's a really great story of how they're streamlining developer productivity at eBay. Thanks, everybody.
Yeah. Live for you. Heat mob.
All right. Hi, guys. My name is Paul, and I work on the NPD team for eBay. And NPD stands for New Product Development. It's a small group that was formed that was given permission to get onto the public cloud. eBay for a long time has had their own on-premises servers, and we were all developing on that infrastructure. So it's really, really exciting to move from the infrastructure that we had to the public cloud, and it was the right time for us to move on to public cloud. There's a lot of momentum, a lot of great companies were coming out with awesome things that we just kept on hearing about but never got to actually use. So looking at the slide, we have to the right, we have three main focuses for our team. We want to invest in AI, we want to invest in the public cloud, and we want to be everywhere. So our team has one simple task: find platforms with a large user bases and connect them to the billion listings that we have. So we're able to move all of eBay's listings from our core data centers into Google Cloud. So here is a snapshot of some of the things that we're actually using on Google Cloud. We're using BigQuery, we're using Dataproc for Apache Spark jobs, we're using Cloud Data Flow, Data Studio for visualization, PubSub, Google Container Engine, everything. So currently, one of our biggest projects is called Shopbot, and it's integrated onto Facebook Messenger, and that is running on GKE. And all of our listings, they're running on Bigtable. So the humble beginnings of our group was in about 2015, just a little over a year and a half ago. We were let loose. We were given permission. We created one project, eBay-N, and we were experimenting every day. We were figuring out the best ways to do things. And a lot of us, we had to figure out how we wanted to change from the old mindset to the new mindset. But nothing was in production. We were chasing every new technology. We were debating each other. Did we want to use Java? Did we want to use Scala? Do we want to use this? Did we want to use that? Everything was debatable at that point. And we had demos every single day. Someone else had something to show you. Our vision team was coming up with new things. Our AI teams were coming up with new things. And it was a lot of fun. And everyone was an editor, which, as we soon learned, became the whole issue of too many cooks in the kitchen. But we've learned a lot, and that's the story that I want to help tell you guys today. As Dana mentioned earlier, teams organized by groups, such a simple way of allowing us to manage the permissions in the best way possible. Before, we were adding everyone as an editor. So if someone new joined the team, they needed edit access. And also, we allowed the teams to manage their members as well, and also to give much more granular IAM policies. And this was the preparation that we needed to get into production. So as I mentioned before, we had one project. So this is how I got involved with infrastructure. Was we needed to create more than one project. And creating everything in one project was very difficult. And imagine trying to create it in 1, 2, 3, 4, 5. It just exploded. We realized we needed to split things up more than just separating non-production and production environments. So we went from managing one project to over 10, and we're planning on adding more. Well, from managing just under 30 engineers, and now we were preparing to handle 100 plus. We went from one initiative that we're working on now to building out a platform that will scale to many initiatives moving forward. So this is currently how we are organizing a lot of our infrastructure. So at the very bottom, you can see in blue, NPD shared. This is where our Google Container Registry sits. And instead of publishing to each individual project, we've given permissions for those Google Container Engine clusters to pull from one particular project. Then we also have restricted and PII data. So we needed a separate project for that. And that has that's where we're running Vault and running our PII data services. And that has lockdown IAM policies, completely separate from everything else. Then we have our catalog. Where is everything located? Where are all our listings and our user identity data going to be located? So that way it can scale from one project, one initiative, N1, to N2, to N3, N to the N. We wanted to build things in a way where we didn't have to redo things later. So this is where Terraform comes in. How did we create all these projects? If I were to create them by hand, it would have taken forever. And we had we had initially taken a look at Terraform a while back, and it's just grown so much, as Dan has shown you. All of the different resources that they've been providing, it was the right time to really embrace it. And knowing how much and how hard they're working on bringing the latest and greatest resources, I'm confident that we're going to try to manage as much of our Google Cloud projects as possible with Terraform. So what did we need to do? We needed to create all these new projects. We needed to create the separation between non-production and production environments. We needed to create service accounts. So within our GK clusters, we have role-based access, and each namespace would get we use team-based namespaces to create the permissions required, so not everyone was sharing permissions together. We were managing the backends and creating the load balancers. We're also managing the firewall rules, amongst some of the most important things that we've been using Terraform for. So when we created the project, the most difficult part was separating the billing ID, which you can't quite automate, and I don't think that you really do want to automate that. We needed to set the IAM policies for all the groups. We needed to create custom subnets because we needed to peer all our networks together instead of communicating over global load balancers. We were using internal load balancers. And we also needed to spin up a GK cluster in each of these projects. Whoa. All right, it's not just me, or not just the in-house. So we also use Terraform to create the service accounts. And for example, we have some complex permissions between separate projects. So for example, bot service from the N1 project needs to call Bigtable in the shared project. So let's see if I can run a quick demo here. So this is how we are going to create projects. There are so many different teams that are interested in getting onto Google Cloud projects. So we've been getting so many requests that we really needed to find a quick way to get a small project up for them, get them sandboxed in, and get them. And it looks like I'm having some connection issues. So, well, let's skip that for now. It does work. And but this is done in a way through modules. As you guys have seen in some of the other tracks, modules are very powerful when they're harnessed in the right ways. And they also add a layer of safety. So basically, what we wanted to be able to do was to be able to create a project for other eBay employees through a simple pull request. So if someone wanted to add a project, they could create this module, send it to us for review, and we'd get that up for them really quickly. And then when they were done, we could tear it down, and then we would provide them more information with more advanced modules that give them greater control over their projects. So the way that we've been organizing all of our modules is in two ways. Vertically, per project, so you could manage load balancers, your GK clusters, your GC instance groups, and create some project-specific IAM policies, and also maintain your network, all within one project. But we also had the need to span multiple projects. So we have horizontal organization through DNS and firewall rules to maintain our network peering, to maintain those cross-project service account permissions, and also to maintain broader IAM policies. So basically, by joining one of our Google groups, you basically get view access for a majority of the projects. So something like that was maintained there. And this is kind of a visual representation of how it would look. We would have our shared project modules at the very bottom. So everyone will be able to reference the Google Container Engine names, the subnetworks, all of the different IAM policies that are available there for that individual project. Then we will combine more of those modules together to make them more useful, and then also align them horizontally and vertically from there. So I've talked to you about some of the growing challenges that we've had when we first moved on to Google Cloud Platform, the shift from deploying on VMs to deploying on containers, the shift from the data centers that we've owned to the public cloud. And one challenge that we still have is we're always doing the latest and greatest. We're always joining alpha. We're always joining a beta. And we don't always have support for that with Terraform. So we'll have to kind of manage that ourselves until that becomes available. But we've had some great turnaround time from the team at Google in making sure that these resources come up as quick as possible. Another reason we're very excited is being able to deploy anywhere in the world. We don't know where we're going to find our next billion users, but we know they're out there. They're all throughout the world. So being able to deploy resources in a consistent manner across the world was really important to us. And another thing is creating the review process and the discipline to manage infrastructure as code and to automate that as much as possible. With that, this is how you can reach Dana on Twitter at Danwell, and she also provided the Slack channel. And this is how you can reach me on my Twitter handle at Straternite. And thank you very much, guys.